So we're going to have to use a different technique if we're going to have even powers on both sine and cosine, or in this case we just have cosine, but it has an even power. So we're going to have to use what we're called either the double angle or the half angle identity, depends who you ask. I like to think of it as a double angle identity because we're going to double the angle x inside of the square. So here they are right here. These are just facts from pre-cal with trig, and we're going to use that to help us solve this integral right here. So let's see here. We got integral of cosine squared x. And what I'll just do is I'll just straight up copy this formula. Cosine squared x becomes 1/2 plus 1/2 cosine of 2x. All right. And then let's see, next, well, I could just integrate, all right? If it's not obvious, though, I can also split this up. 1/2 dx plus 1/2 cosine of 2x dx. Maybe you prefer that because, well, then it's obvious. The 1/2 dx becomes just 1/2 x because the derivative of 1/2 x is 1/2. This is probably the harder part right here. Maybe it's not obvious how to proceed here. So you can do it just using substitution. So the details for that would be, well, I've got a 2x, and that's the problem. So I'll let u equal 2x. du is 2 dx. And then let's see, I want to get a just plain old dx. So I'll make that 1/2 du is dx. And then from there, I can see that that would be equal to just this one little piece here. That would be 1/2 cosine of 2x becomes cosine of u. dx becomes 1/2 du, and which is 1/4 cosine of u du. All right, so I do all that work out. What do I end up with? Well, I'll just integrate. 1/4 comes down. Cosine of u is the derivative of sine of u. But what's my u? My u is equal to 2x, so I'll just make that sine of u, sine of 2x. And then I've done a bunch of integrating, so I'll add my plus c. And there's my final answer. But let me just say this. This takes a little bit of time to do all this work. I don't think it's the quickest way of doing it. If you have a simple substitution problem, all right, something that doesn't take a whole lot of brain power, maybe you could do it in your head, then you want to do it in your head. And so let me talk about how I do simple substitution problems mentally. Okay, so what I'll do is let me just erase this piece right here. Okay, how would I do that substitution in my head? All right, so ignore all this purple stuff. Now I'm just going to do this mentally. Let's think about it this way. All right, cosine of 2x. If I want to integrate it, another way of thinking about that is I just want to take the I want to take the derivative of something to get cosine of 2x. So this cosine is the derivative of sine. All right, so there's the sine there. That won't work though, because let's actually take the derivative. Chain rule says a 2 comes out and I would get 2 here instead of the 1/2. So let's see, I want to end up with 1/2, so I just need to have a little multiplier here. 2 times what is 1/2? 2 over 4 is 1/2, so make that 1/4. Another way to think of it is, it's a simple case here. If you just have like the 2x, really you're just going to divide by that 2. 1/2 divided by 2 is 1/4. So in simple cases, I recommend doing it in your head, but if you have the time or you just don't feel comfortable doing it in your head, then definitely do this extra workout here in purple. In any case, there is my final answer. So let's take a look at another. All right, so here we have both sine and cosine with those even powers. If one of the powers was odd, we would use simpler techniques. But since they're both even, we have to use our double angle identities right there. And I'll have to use both of them. So let's apply both of those. So sine squared of x, that becomes, here's the formula. Oh, well, it's z's instead of x's. No problem. Z, 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 and z. So sine squared of z becomes 1/2 minus 1/2 cosine of 2z. All right, what about cosine? Well, the same thing. These are easy formulas because one of them has a minus. If it's cosine, they're both cosine, there's a plus. If it's sine to cosine, a negative pops up. And sure, that's 1/2 minus 1/2. Sorry, we're doing cosine here, right? So plus 1/2 cosine of 2z. All right, so we'll multiply all that out. So 1/2 and 1/2 becomes 1/4. To the inside, that's negative 1/4 cosine of 2z. To the outside, positive 1/4 cosine of 2z. And then the last two, we have negative and negative. That's negative 1/4 cosine of squared of 2z. We'll put all these in parentheses with the dz here. And yeah, those will cancel like that. Easy enough. Okay, let's see, those cancel, and it's up to you whether you want to leave the 1/4 in there or maybe you want to factor them all out. If I factor them all out, I'm left with 1 minus cosine squared of 2z dz. Okay, so now 1 minus cosine squared of 2z. Oh, hold on. How do I proceed from here? Well, that's not too bad. We've got cosine squared of 2z. If I come back up here, uh, let's erase these z's that I kind of wrote in there. All right, so here's the original formula, and I only care about this top one now because I'm dealing with cosine. X could be anything. X could be z. X could also be 2z, and it would still work. So if I put a 2z here, then I'll put a 2z inside of there, which of course 2 times 2z is 4z. So I've got 4z, so I'll just apply that same formula with a 4z instead. 1 minus quantity 1/2 plus 1/2 cosine of 4z. Basically, whenever you use this formula, whatever's on the inside doubles. All right, and let's see, dz. Let's simplify a little bit here. Take that negative and multiply it out. 1 minus 1/2 is 1/2 minus a 1/2 cosine of 4z. And again, you may dislike fractions as much as I do and want to factor out that 1/2 to get 1/8. 1 minus cosine of 4z. Okay, so now as soon as you get rid of all these square things, there's no square there thankfully, we've got just cosine to the 1 power. So yeah, I could just do this integration directly, bring down that 1/8. 1 integrates to z as my variable, and now minus cosine, I'm going to do this mental substitution thing. So cosine, the derivative of sine is cosine. So minus sine of 4z, but I can't just say that because a 4 is going to pop out if I do that. There's no 4 up there. Well, that's okay. I'll just have a 1/4 here to cancel that out. And if I take the derivative here, 1/4, the 4 cancels with the 1/4, sine becomes cosine. I'm good to go. Plus c. And then if you want, you can either leave that as your answer or multiply out that 1/8 minus 32nd sine of 4z plus c. And that's my final answer.